Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar, your educator for this course. States of matter. Today we begin with lecture 8 from the course, but make sure you watch the previous ones before viewing this one. So in the last lecture, what we learned was the Boyle's law. And what was the Boyle's law? Well, at constant temperature, the pressure of a fixed amount of gas, this is inversely proportional to the volume. So we had a detailed discussion on the Boyle's law in the last lecture. And in this lecture, we would be discussing a few problems based on Boyle's law. But before moving further, please, if you have not watched the previous lecture, do watch that, because without that, you are not going to understand these questions very well. And these questions, they will help increase your knowledge further, increase your understanding further, plus they will be helpful to you when you're going to solve the questions yourself as practice problems as well as in your examinations. So the first numerical is a sample of air has a volume of 500 decimeter cube and a pressure of 1 bar. What additional pressure is required to reduce the volume to 200 decimeter cube at 30 degrees Celsius? Now, before I tell you the solution, one important thing for you people is that you should try to do the questions yourself. Once I have read the question, just pause the lecture, try the question yourself, and then check with the solution. If you've got the solution correct, that is going to be very good. You have really understood the topic very well. But in case you are not correct also, then also you will be exactly knowing what is the mistake that you are doing. So that would increase your learning, right? So please do pause it first, and then after that you can watch the solution. So now when we talk about the solution of this question, first thing is we have a volume being decreased from 500 decimeter cube to a 200 decimeter cube volume, and pressure of 1 bar is being increased, and we have to tell that additional increase in pressure. So what you have to see over here is, are the other two quantities fixed over here? Yes, we have a sample of air, so there is no change in the mass of the air. It is going to be the same mass of the air that we will be having before and after the change in the volume and pressure. Similarly, there is no change in temperature. There is only 30 degrees Celsius temperature that is mentioned. So we have the two quantities, that is mass and temperature, being fixed, and the other two quantities, they are going to change. Right. So now I hope you can understand very easily that it is going to be the application of the Boyle's law. Why I'm trying to tell you to focus on these four quantities which is going to be fixed, which is changing, is because this is not going to be the only law that you will be learning. There are going to be other laws as well. So you should be able to understand which law is going to be applied. Right. So now you know that this is the application of the Boyle's law. It is going to be a very simple question. So the initial pressure P1 is 1 bar. The initial volume V1 is 500 decimeter cube. The final volume V2 is 200 decimeter cube. And final pressure P2 is something that we have to find out, and which is very easily determined from P1 V1 equal to P2 V2. So just put those values. What you will be getting, the value of P2 is 2.5 bar. But this is not the answer that you have. What you are asked in the question is what additional pressure is required. This is going to be the final pressure. So what are you going to do? The additional pressure is going to be 2.5 minus 1 bar, that is 1.5 bar. Easy enough, I hope. Nothing difficult at all. So the second question is that a weather balloon has a volume of 175 liter when filled with hydrogen at a pressure of 1 bar. Calculate the volume of the balloon when it rises to a height of 2000 meter where the atmospheric pressure is 0.80 bar, and assume that the temperature is constant. So what all is given to us over here? The initial pressure, that is 1 bar. The initial volume of the balloon, that is 175 liter. The final pressure 0.80 bar, and the final volume of the balloon that is going to be found out, right? So one thing that you have to understand again over here is that first of all, the mass of the hydrogen gas is fixed. We have filled a balloon with hydrogen, and after that there is no change in the mass of the gas, right? And the other thing, the temperature is constant. So what are you going to apply over here? Again, this is going to be the applications of the Boyle law. So P1 V1, this is going to be P2 V2. So quickly just put in the values. What you will be getting, the value of V2 is going to be 218.75 liters after you have put in all the values, right? It is going to be a very simple question, but there is something more that I just want you to revise over here. The pressure was 1 bar when we had it, assuming it to be the sea level, and when the height was increased, the altitude was increased, the atmospheric pressure, this decreases. So this is something that I've already told you, and this is one very important thing that you have to always keep in mind, that with increase in the altitude, the pressure decreases as well as the density of the air decreases. Okay. So the next question is that a desiccator of internal volume 1 liter and containing nitrogen at 1 atmospheric pressure is partially evacuated to a final pressure of 7.6 mm of mercury while the temperature remains constant. What is the volume of the gas at this stage, right? So first of all, what you should understand is what is a desiccator. Although it is not required in the question to understand what is a desiccator, well, it is going to be a closed container which is used to store dry samples in a dry atmosphere. Okay, so this is what is a desiccator. Now we have a desiccator of internal volume 1 liter. Okay, and it has what gas into it? It has a nitrogen gas at 1 atmospheric pressure. So this is the P1 and V1 that is given to you, and then it is being partially evacuated to a final pressure of 7.6 mm of mercury. The temperature remains constant, and what you have to tell is the volume of the gas. So again, I would like you all to first pause the lecture and solve the question yourself and then check with the answer. Now, if you've done that, well, what have you done? I am very sure that what you have done is that P1 V1 equal to P2 V2, and you have found out the volume of the gas, right? But actually this is not correct. It is not correct because one thing is constant, that the temperature remains constant. But what have we done over here is that we have partially evacuated the gas. This means is that we have moved out some of the gas, nitrogen gas, from the desiccator. So the mass of the gas has changed. Okay, and after the mass of the gas has changed, we have some mass of the gas again in the desiccator, and this mass of gas is exerting a pressure of 7.6 mm of mercury. Okay, so now what is going to be the volume? Well, the volume is going to be again constant, that is 1 liter, because the volume of the desiccator has not changed, right? So the gas is going to occupy that much space that is given to it. What we have done to change the pressure is to evacuate the gas or decrease the mass of the gas that was present into it. Okay, it is not because that there has been some change in volume that the pressure has changed from 1 atmospheric pressure to 7.6 mm of mercury. Okay, so I hope this is clear to you people, that the volume of the desiccator is constant. The volume of the desiccator evacuated gas will also be 1 liter. So the volume of the gas is going to be 1 liter. I hope this is very clear to you people, that unless you are changing the pressure and volume both at constant mass and temperature, you are not going to apply the Boyle's law. Fine. The next question is that two closed rigid vessels of 10 liter volume, they are connected by a tube of negligible volume. The valve present between them is closed and a gas is introduced in one of the vessels such that a pressure of 2 atmosphere is attained in the vessel. Maintaining a temperature of 300 Kelvin, the valve between the vessels is opened and now the pressure of the gas becomes 1.5 atmosphere, 1 atmosphere, 0.75 atmosphere or zero point 0.5 atmosphere. So if you pause the lecture and now you are switching it back, let us see the solution. So this is, the container that we had. Okay, so this is a two vessel container. This is one vessel which has a pressure of 2 atmosphere and a volume of 10 liter, and the other container, this is also of 10 liter volume, but we do not have any gas over here, right? So it was in this chamber that we put a gas which is exerting a pressure of 2 atmosphere. So Pi initial, you can say, is going to be 2 atmosphere. The volume is going to be 10 liter for this gas, right? The final volume after we open the valve, right? So first the valve was closed, now the valve has opened up. So when the valve opens up and this area of the container, the tube is of negligible volume, so what you will be taking, the final volume will be as 20 liter, 10 plus 10, and now the whole gas is going to spread into this. Okay, so again the mass of the gas is same, right? The temperature is also constant, so you can now apply the Boyle's law. So what is going to be the final pressure? Well, now it is going to be very easy. Just simply put P1 V1 equal to P2 V2 or Pi Vi equal to Pf Vf, where Pi means initial and this is going to be final. So we have 2 into 10 equal to Pf into 20. So the final pressure becomes 1 atmosphere. Right? So I hope this is clear. You had a valve in between, so there was limited volume of 10 liter, but the moment you opened it, the volume of the container, this increased to 20 liter. So the pressure, this had to decrease for the fixed amount of gas at constant temperature. So the next question is that in a container of 1 liter fitted with a piston, a wooden block is placed at the bottom of the container and the container is filled with a gas at pressure P atmosphere. Now the piston is pushed downwards to increase the pressure by 100% and decrease the volume to 750 ml. Find the volume of the wooden block, right? So try it and then listen to the solution. So what does the question say? The question says that we have a container of 1 liter which is fitted with a piston, right? So what is the piston going to do? Well, if we apply pressure on the piston is going to come down, and when it comes down, it is going to decrease the volume of the container. And if it is having some gas in the container, you can understand that with a decrease in volume, there is going to be an increase in the pressure of the gas. Fine. So what is going to happen when we push the piston downwards is that the volume of the container, according to the question, this decreases to 750 ml and the pressure, this increases by 100%, which I have written as 2 atmosphere. So let us see how we've calculated that. So initial pressure was P atmosphere. The final is going to be P plus 100% of P. So this is going to be P plus P, that is 2P atmosphere. Right? Now the volume of the gas is what you have to understand. The volume of the gas, this is 1 liter. No, this is not 1 liter. The volume of the gas initially is going to be 1 liter minus the volume of the block, and the final volume is going to be 750 ml minus the volume of the block, because the gas is going to occupy only that much space that is given to the gas, right? So I think you now understand why from the very start of my lectures that I have been trying to explain you this very important thing, that the gas is going to occupy that much space that is given to it. Okay. Now the rest of the thing is going to be very simple for you. We have the pressure, the final and the initial, the volume, the final and the initial. What you have to do is simply apply the Boyle's law. And the other two things, well, you have to the temperature is not mentioned over here, so that is going to be constant, and you had taken a fixed amount of gas, so that is also constant. So we have PIVI equal to PFVF. Just quickly substitute the values. What you will be getting as the volume of the wooden block is going to be 500 ml. Okay, so what I have done over here is just 1 liter. I have converted this into 1000 ml because the other part volume was in ml, right? So 1000 ml and 750 ml. The rest calculations, I think they are going to be very simple for you. Now the next question is based upon the graphs that you learned in the last lecture, right? So the question says, which of the following curves represent or represents the Boyle's law? So these are the 4 curves. They are in front of you and you have to tell which of them or which of these are going to represent the Boyle's law. And if you've watched the previous lecture, you will be able to get this correct. But in case you have not, please do watch that. Otherwise, you are going to make a mistake. In fact, this is one of the questions that we posted on our Facebook page. And most of the students, they could not find out the exact answer. Okay, so please, I hope you all have watched the previous lecture before viewing this lecture. So based upon that understanding, you can understand that when we draw a graph between P and V, it is a rectangular hyperbola and this graph is correct. Okay, so you can watch the previous lecture. I will not be able to discuss everything again. This graph is going to be correct. Okay, when I will be leaving this graph over here first, I will be coming to this graph. Okay, so we have PV versus V. The graph I told you in the last lecture was PV versus pressure, but at the same time I told you that even if instead of pressure we have volume over here, the graph is going to be again this one same graph, right? So with increase in volume, the product of pressure and volume is not going to change, because with increase in volume the pressure will be decreasing in such a way that the product remains constant, so there will be no change with increase in volume in the product, right? The next graph was pressure and 1 by V. So again this graph we have done. This is a straight line graph, which is passing through the origin, and this is also correct. Now coming back to this graph and this graph, they are essentially the same. Here we have taken pressure versus 1 by V, and here we have taken 1 by P versus pressure. Because pressure is going to be directly proportional to 1 by V, or we can say that volume is directly proportional to 1 by P. This is going to be essentially the same thing. There is no difference. So what do we have over here? Well, all the choices, they are going to be correct. And if you've not understood, please do watch the previous lecture. Okay. So now I have the last question for today. Which of the following curves does not represent the Boyle's law? So again, this is going to be a question on the graphs related to the Boyle's law, and I hope you can now understand these are the questions which are frequently asked in the examination, and you should be thorough with them. So the 4 graphs, they are in front of you and you have to choose which one is not going to represent the Boyle's law. The first one we have already seen in the last question as well as in the previous lecture, that pressure is going to be related to volume in the way that we will be getting a rectangular hyperbola. Right, so this is the graph which is going to be correct for the Boyle's law. Similarly, this one we just now did, that pressure and volume product is not going to change with increase in volume. So this one is also correct. Now you have to choose between the choices B and C. So let us see this graph over here, which is between log P and log V minus 1. That means between log 1 by V and P. So let us understand this one over here because we've not done this in the previous lecture. I did not do it purposely because I wanted you to attempt this question first yourself. Okay, so what are we going to do over here is that we have the Boyle's law equation P equal to K by V, and what we will be doing is that we will be taking log on both sides. So what we will be getting is log P equal to log K by V, which we can also write as log P equal to log 1 by V plus log K. I hope this is understood by all of you. The next we have is going to be just putting these as Y, log P as Y, log 1 by V as X, and log K as C. And if I put a 1 over here, that is also not going to make a difference. So this 1 over here is going to denote my M, which is going to give us the slope of the line. Okay, now when I draw the graph for this, log P on the y-axis, log 1 by V on the x-axis, what I will be getting is C as the intercept on the y-axis, right? So this is going to be my point, which is going to give us the value of log K. Okay, the next we have is M, and M over here is 1. When this is going to be 1, we will be having the slope of the line 1, which means tan theta is 1, which means that the value of theta is 45 degree. So the angle which the line is going to make with the x-axis, or a line which is parallel to the x-axis, is going to be 45 degree. So this is also going to be the correct graph for the Boyle's law. Okay, I hope this is clear. So obviously what you can deduce from here is that C choice is going to be incorrect, because this is not a you have to give one choice over here. This is a single correct answer, right? So choice C is going to be wrong. So now one thing that you have to understand is this graph as well, because this can also be a way in which we can represent the Boyle's law with just one change over here, that this would be the graph between log P and log V rather than log 1 by V. Let us understand this, because you should have a thorough knowledge. My duty is that I give you just not how to just make one choice being ruled out, but I just want to give you a thorough knowledge. Whatever comes in the examination, you should be prepared for that. So according to the Boyle's law, what we have, the equation is P equal to K by V. So what we can write this now as log P equal to minus log of V plus log of K, right? And now this would be my Y equal to mx plus C. So this is again going to be a straight line graph. Log C, this is positive, so this is going to be in the going to be a positive point. From there we will be having the C intercept. So this is the value of log K, right? And now because here we have log V to be X, and M is now going to be minus 1. So if I put over here a 1 over here, what I will be getting M is as minus 1. So M minus 1 means that this is going to be a negative slope. It is going to decrease. What is going to be the value of theta if M is going to be minus 1? It is going to be tan 135 degree. So tan 35 is going to be giving us this value as the theta. So this is a graph not for log P versus log 1 by V, but this is a graph which is going to be for log P versus log V. Okay, so I hope this is also clear to you, although this is the wrong choice, but you should know how this would have been the correct choice, log P versus log V. So I have been able to, I hope, tell you all the graphs which are related to the Boyle's law now, and you will not be making any mistake. So that would be all for this lecture. The next lecture we would be talking about the Charles law again, which is going to be another very important law. And if you've not subscribed to the channel till now, please do that, and also do click on the bell icon so that you get a notification the moment we put up a new lecture for you. And also, if you have any doubts related to what I am teaching you, or you have any other queries related to what we are teaching you, if you are having difficulty in solving your queries questions, please feel free, put them in the comment section, mail them to us, join us on our Facebook page by the same name again, H2O Chemistry. We will be glad to help you people. If you've liked the lecture, one last request, please do click on the like link before leaving. Thank you and have a nice day. God bless you.